Let's take our next question, that is question number 28. Now this question belongs to section of electromagnetism, topic potentiometer. Now the potentiometer wire AB having length L, this wire has resistance 12R, is joined to a cell D of EMF E and internal resistance R. A cell C having EMF E by 2 and internal resistance 3R is connected in this manner. The length of AJ, which let's consider this as small l, is required to be found in terms of capital L. Now, in this case of potentiometer, basically whatever potential is for AJ segment will be equal to E by 2, so that no current flows through this galvanometer. So what we want is we have to find the potential of AJ and equate it to E by 2, and we can easily find our answer. So let's start with the solution. So very primary thing, what is the current due to the driver cell in the circuit? It would be E divided by 12R plus R. 12R due to the resistance of AB and internal resistance, this would be E by 13R. Now potential of AB segment would be current in the driver cell into the resistance of AB, which would be equal to 12 E by 13. Now if we want to find the potential of AJ, it will be simply equal to total potential of AB by total length into required length. So from here you will get 12 E by 13 into small l by capital L. This is the potential of AJ, and this potential should be equal to E by 2 of the cell which has been attached here as C. So just by equating, you will get this and this will be cancelled. Small l will be 13 capital L by 24, right? So let's see what is the length of AJ segment. As far as the given options are concerned, out of these four, option number 4 is the right answer to this question, right? Let's move ahead and see question number 29. This question belongs to the section oscillation and waves. So as per the question, a string of length 1 meter and mass 5 gram is fixed at both ends and the tension in the string was 8 Newton. The string is set into vibration using an external vibrator of frequency 100 Hz. The separation between the successive nodes on the string is close to, basically we want lambda by 2 here, right? So let's start with the solution. If you have a string which is tied between 2 points and any wave pattern is set on this, so the closest distance between the two nodes would be always equals to lambda by 2. So what we need is this lambda by 2 for us, right? In order to find the wavelength, we first have to find the velocity in this case, because we are aware that lambda can be written as velocity by frequency. Now velocity would be given by under root tension by mu, this is mass per unit length of the string. So lambda would be equals to under root 8, mass per unit length would be 5 into 10 to the power minus 3 into what is the frequency? 100. Solving this, you will get 0.4 meters. So the closest distance between the two nodes would be half of this lambda, that is 0.2 meters or 20 centimeter. So which is the best suited option among these? Option number 4, right? Let's move on to the last question of this paper. Now this question belongs to again kinematics section, that is mechanics part. A piece of wood of mass 0.03 kg is dropped from a top of 100-meter high building. At the same time, a bullet of mass 0.02 kg is fired vertically upwards with velocity 100 meter per second. The bullet gets embedded into wood and the maximum height to which the combined system reaches above the top of the building before coming to rest is. So let's start with the solution. For this, let's assume a case that this is that building which we are talking about. This is the ground, right? Now from here a wooden block was left or dropped at u is equals to 0 and this was fired up, right? And the velocity of this was 100 meter per second. This was the bullet. They met here at some point. So the distance traveled, the meeting happened at time t, this height was h, this was y, and distance covered by this one would be h minus y, right. At the time they contact, there will be the block will be having velocity vb downwards and bullet will be having velocity v small b upwards, right. Now let's try to solve this. So first of all, the y would be equal to half into g into t square. So we have to find what is the value of t, right. As per the relative concept, I will say that h would be equal to 100 into the time at which they will meet. We very well know the concept of relative velocity. From here you will find t is equals to 1 second, right. That means y is simply equals to 5 meter. So now we know where they collided in this situation. Now the combination will have some velocity. We need to find the final velocity of this combination. Let's take that as Vc, that is the common velocity. So I'll say the total mass of block plus bullet into Vc should be equal to minus mass of block into velocity of block plus mass of bullet into velocity of bullet. Now we need to find the value of V capital B, which will be simply gt, that is equals to 10 meter per second downwards, and value of V small b will be equal to 100 minus gt, which would be equal to 90 meter per second upwards, right, and this is downwards. So this would be negative, this would be positive. Now let's put down the values here in the equation we have got. So 0.03 plus 0.02 into Vc, that is the common velocity we don't know, as per sign convention, minus 0.03 into 10 plus 0.02 into 90. From this, Vc would be equal to minus 0.3 plus 1.8 by 0.05, which would be equal to 1.5 by 0.05, and the velocity here Vc would be equal to 30 meter per second. Now from this point, this combination is having velocity of upwards 30 meter per second. So from this level, they will go up to a maximum height of v square by 2g, which is the formula we already know. So what is the maximum height from the point of collision? H max would be Vc square by 2g. Solving this, you will get 45 meters. So from this point, as evident from the diagram, they will go up by till this point, where this height in total would be 45 meters. And what was this y? It was 5 meters. So from the top point, what is this distance traveled? It would be 40 meters, right? So let's see which is the best suited option for this question. Among the 4, option number 2 is the right answer. So I hope this was clear to you. I wish you best of luck for your results. Let's meet in the next paper's video solution, that is of the evening session. Till then, take care. Bye bye.